We've looked at simplifying and gathering together and separating logarithmic and exponential equations, and we've switched back and forth between logarithmic and exponential expressions. And now we're going to use that idea that the exponents in logarithms are inverses of each other to solve equations of different types. First type are the type of exponential equations in which you have like bases. Here I have a base of 4, here I have a base of 4, and all I have to do is pull those exponents out and solve them separately. The second type is when the bases, and we're going to call them hidden bases, it's when this 9, is actually a power of 3. So we can actually change that 9 to 3 squared to the x power, which is then 3 to the 2x. And then, since we now have like bases, we can solve the numerators. 4x minus 12 equals 2x, and we solve that, and we get x equals 6. But then there are those situations where we do not have the same base, or we have a base only on one side. Unlike bases, we will take the log of both sides. So the log of 2 to the x and the log of 15. Well, from yesterday, we know that the log of 2x is equal to x times the log of 2. And at this point, if I divide both sides of this equation by the log of 2, then I'll have the x by itself, and I can certainly calculate log of 15 divided by log of 2, and it's 3.907, or approximately 3.907. And, as we talked about yesterday, the natural logs act just like log base e. So natural logs and a base of e in an exponent problem are inverses of each other. So if I have 3 times e to the x equals 31, we get the e part by itself by dividing 3 into both sides. And now we are going to take the natural log of both sides. And again, that undoes it. So we have x equals, and then the natural log of 31 divided by 3 is 2.335, approximately. Here's another problem where we first start off by dividing 3 into both sides, and now I have a log of 2. And so I'm going to take the log of both sides. 2 to the x equals 14. I'm going to take the log of both sides. That x here will come out in front of the log 2. The exponent x would come out in front. And then again, I'd divide both sides by the log of 2. So log 14 divided by log 2 is 3.807. Now we'll go the other way. These are log problems that we're going to use exponential facts to solve them. In this case, if they have the log base 3 in both, then we just take the x minus 2 and the 9, and we solve that, and we get x to the 11th. That's just like having the same base on our exponents. All the others, we're going to take this base 2, and we're going to raise both sides of the equation to that base. Here you can see this is a log of 3. We raised them both with a base of 3. Here it's natural log, so we took e, raised everything to the e power. And we simplify from there. So 2 times the log base 2 of 3x, that is the 2 and the log 2 cancel out, and so I have 3 to the x, 2 to the 4th is 16, divide both sides by 3, and x equals 13. Same thing here. Base is 3, take both sides of the equation, put them with a base of 3, and these cancel. The 3 to the log base 3 cancels itself out. I'm left with 2x minus 1 on the left-hand side. 3 to the 4th is 81, and solve that, and we get x equals 41. Same thing here. Natural log of 3x plus 2 equals 3. We're going to raise both of them to put them in an exponent with e as its base. That leaves me with these. The e to the natural log cancels itself out. I'm left with 3x plus 2 on the left-hand side and e to the third power on the right-hand side. Now, I kept that e to the third power and not going to actually calculate that number until I get right here to the very bottom. All right, keep it, just let it be, let it act like a variable until you can get everything ready to go, and then you do e to the 3, and you don't round anything, you then subtract 2, and then take that answer and divide by 3, and you'll get x equals 6.029. Couple more examples here, and this is probably about as difficult as it's going to get. Here we have the natural log of x plus the natural log of x minus 1. Well, that's addition, so it started out being these being multiplied together. Natural log of something multiplied together, expanded, is addition, so when I bring it back together, it's multiplication. And equals the natural log of 6, so I simplified that. Now, if I have the same base, I have the base e. A log base e is a natural log, so I have the same base, and so I simply solve the thing that I'm taking the natural log of. So x times x minus 1 equals 6. Distribute the x, so I get x squared minus x equals 6. Subtract 6 from both sides. X squared minus x minus 6 factors to be x minus 3 times x plus 2. So x would either equal 3 or negative 2. But we can't take the negative natural log. We can't take the natural log of a negative number. So x cannot equal that negative 2 value. And lastly, 3 times the natural log of 3x minus 2 minus 5 equals 7. Start off by getting this natural log thing by itself. So we add 5 and divide by 3. And now, since we don't have the same base, we need to raise both sides of this equation to an exponent with e as its base. And e to the natural log cancels itself out, leaves us with 3x minus 2 equals e to the 4th. Same thing, we'll wait until the very, very end to calculate e to the 4th. So calculator-wise, e to the 4th minus 2 divided by 3 is 18.866 approximately.